So now that you've been given an overview of the runtime exception handling methods in Java Completable Futures, let's go ahead and take a deeper look into how these can be applied in practice. So we'll look at some examples here. This example we're going to look at, which also comes from my EX8 folder in my GitHub repository, shows 3 different ways to handle exceptions with Completable Futures. And we'll take a look at the use case. It's kind of a fun use case. So what we're going to do here is we're going to use supply async, which is our good old factory method, and we're going to give it a computation to run in a thread in the common fork join pool. And that thread is going to go ahead and get the value of, or it's going to create a big fraction whose numerator is 100 and whose denominator is some variable. And we can set what we want the variable to be. If you look at the test, you'd see that it has several different values. Keep in mind that if you give a denominator that's got the value 0, that will trigger an arithmetic exception because you're trying to create a big fraction with a 0 in the denominator, and that's clearly going to be a problem. So if we don't do anything to handle the arithmetic expression if/when it occurs, then we'll end up with an unhandled exception, and that will terminate the program. We really don't want the program to be terminated. That would be bad. That's not graceful. It's not resilient. It's not an example of handling partial failures, et cetera, et cetera. So let's take a look at a couple different ways to deal with this. One way to do this is to use the handle method. And what's interesting about the handle method, it is designed in such a way where it can handle both exceptional or normal completions with the same API. So here's what it looks like. You can see that after we call supply async, of course, we get back a completable future. And at some point, that completable future will be triggered when the computation is done. And it either finished normally, in which case the parameter that's passed to handle will be fraction that is non-null. That would be one case. If everything goes well, then the fraction parameter that we see here is non-null. Everything's copacetic, everything's fine, everything's hunky-dory. But if an exception occurs, then the EX parameter will be non-null and fraction will be null. And keep in mind that the handle method is always called regardless of whether an exception is thrown or not. It just allows us to figure out whether an exception was thrown or not. So as you can see here, what we're going to do is when handle gets called, it's going to take this parameter here, which is going to, I believe it's a by consumer, and it has fraction and EX. These values are mutually exclusive. Either fraction is null, in which case EX is non-null, or fraction is non-null, in which case EX is null. So if the fraction is null, then the exception path will swallow the exception, meaning it doesn't propagate. It's called error hiding. And it returns big fraction 0. And big fraction 0 is just a 0. So what we're doing here is we're converting an exception into a 0. May or may not be the right thing to do. I'm just doing this to illustrate that you could do it. Otherwise, if all goes well and we have the normal path where there was no exception, then we're just going to take the fraction, because we know it's non-null, and we're going to multiply it by some big reduced fraction to get a result. So that's the normal path. So here's the exception path where we swallow the exception. There's the normal path where we don't. And in either case, we give back a value from handle. So it'll either be the value that comes from the normal path where we multiply the reduced big fraction, or rather the big fraction by a reduced fraction, or it'll be 0. Either way, it's got a normal value. And then we use the then except method, which will display the result as a mixed fraction, which will again either be 0 or the result of multiplying the big fraction by S big reduced fraction. So you can see how handle can basically check to see if an exception occurred and then do something to compensate for it in some way, like changing the value, and then proceed on as if nothing had gone wrong at all. So that's one way of dealing with exceptions. Let's take a look at another way to deal with exceptions. This is the exceptionally method. And this is also going to be used to handle either normal or exceptional conditions. So as before, we call big fraction value of, which will throw an exception if the denominator is 0. We use supply async to do that. Then if there is no exception, we're going to call then apply, and that's going to go ahead and multiply the non-error case, just the fraction that came back from the supply async factor method call, by s big reduced fraction. That's the case where everything goes well, no exception is thrown. However, if an exception is thrown, control will transfer from supply async, skip over then apply, and be handled by exceptionally. And this will handle the case where the denominator is 0 and an exception is thrown. And notice what we do here again, just for consistency's sake, is we go ahead and we return 0, masking the fact that an exception occurred. So that's another example of error hiding. You can kind of think of exceptionally as like catch in a Java try-catch block, in the sense that control will transfer to it. So that's basically how exceptionally works. And then in either case, we're either going to have 0 or we're going to have the result of multiplying the created fraction by s big reduced fraction, and we're going to go ahead and use then except to print the result as a mixed fraction. So that's the second way of dealing with things. I think you'll notice that this way is a little bit more subtle in the sense that control either goes here or there. And so there's some interesting runtime behavior that you have to be aware of, that the Java environment knows about, but that's how it controls it. Whereas with this example over here, basically you would get, the handle method would always be called, and then you would decide what happened based on the parameters that were passed to it. The third way we're going to look at is kind of different, and it's got some different semantics. So this is the whenComplete method. And whenComplete, much like handle, but unlike exceptionally, is called under both normal and exceptional conditions. So whether or not we get the normal processing or we have an exception, whenComplete is always called. And you can see what it does is, once again, it's passed this basically this by function, and the values that are passed are either the fraction, if it's, well, the fraction and the exception. And these values, once again, are mutually exclusive. So if fraction is not null, that means it worked. And then we go ahead and print the results as a mixed string. Otherwise, if fraction is null, that means that the exception parameter was non-null. And then what we're going to do is we're going to go ahead and get the message that was associated with that exception. So when an exception is thrown, you can provide a message along with it. And in this case, we're just going to get that message and print out what went wrong. So you can see here that we're going to use EX if it's non-null. We're going to use fraction if it's non-null. Those are mutually exclusive conditions, so we know that one of the two will be true. whenComplete is kind of a funky method in the sense that it behaves like Java streams peak. It has a side effect, but it doesn't change the return value, and it doesn't swallow the exception. Excuse me. So the exception is still going to be propagated up. It's just that we got a chance to do something with the exception. If there was an exception, we could print out its message, for example. And if there was no exception, we could still do something, like we could print out a message, but the exception is not swallowed, and there's no change in the return value. It's just basically like a peak. It's just getting a chance to have some kind of side effect. So that's the end of the overview of handling runtime exceptions part 2, where we walk through a couple examples of how to use these features in asynchronous Java programs that are based on Java completable futures.